We're starting the day with a session on bidirectional charging and also its impact on EV infrastructure and reliability. So, please join me in welcoming Javier Lázaro, Head of Sales at XCharge Europe. Please.
Hi everyone, can everyone hear me? Is all good? Okay, the sound is good. So thank you for the introduction. As you said, my name is Javier Lázaro, Head of Sales for XCharge in Europe. And I'm going to be talking today about bidirectional and microgrids. But first of all, I would like to say thank you to the organizers of this amazing event, Javier. It's massive event. It's probably the best event in the e-mobility ecosystem. So thank you very much. Keep it up. I have been in a few editions, never on stage and never speaking to people with headphones. So please, if I make a mistake, please forgive me. And last but not least, of course, I would like to thank you guys. Yesterday was a party, a lot of beers, Aperol Spritz, and gin and tonic. So I really appreciate that all of you are here listening to the presentation. The presentation is going to take about 20 minutes, and then there's going to be a 10 minutes Q&A. I don't know if you have already said that, but okay, sorry for repeating, but I couldn't hear it. So it's about bidirectional and microgrids and how bidirectionality and microgrids are going to transform the way we see infrastructure, EV infrastructure nowadays. So let's start with the question: who remembers how is to fill up a gasoline tank? Of course, all of you remember, because it's not that far, right? And you might still have a gasoline car, or your partner, or your cousin, or your friend. The filling is quite like an empty process, right? You just fill up, you just insert some liquid on the gasoline tank, and that's it. There is no interaction. There is nothing happening whatsoever. And then the engine burns the gasoline, and that's it, right? So this is something from the past. If I ask the same question in 10 or 20 years, probably a lot of people are not going to remember this process. That's happening. It's happening in Europe. 25% of the cars sold are already EVs in Europe. So this is happening. And what is happening now? The process that is happening now is that we are charging our EVs. If you think carefully, because sometimes we don't wait and think carefully what is happening. What is happening is that it's a full interaction between the car and the EV charger. There are two elements that we are exchanging. Energy, of course, that can go from the vehicle to the charger and from the charger to the vehicle, and data. There's tons of data flowing from the vehicle to the charger and from the charger to the vehicle. What is happening now and what is going to happen next? It's this energy ecosystem. We are going through an energy ecosystem where the charger is going to be interconnected with batteries, with solar panels, with the building, the grid, and all that. All right? So I'm going to be talking about what are the benefits of that. But first of all, let's analyze a little bit of the challenges that Europe is suffering, let's say. What are the challenges that, well, not suffering, but are happening in Europe? So the EV adoption is growing, right? So we are going, in 2015, there were 1.5 million EVs on the roads. 10 years later, in 2025, there are like around 50 million EVs. When I started in mobility in 2018, there were like 5 million EVs, so you can see the trend, right? So the EV adoption is massive, it's happening, and the expectations are even higher. So by 2030, we expect 250 million EVs on the roads in the world and around 55 in Europe. This is massive, and the companies will have to provide the infrastructure to charge all those EVs, right? So it's a challenge. Another challenge that is happening in Europe is the raise of energy cost. So from Q1 2024 to Q1 2025, the price of the energy raised by 49% and is expected to raise another 37% by the end of the decade. So this is another challenge. So all the CPOs, they have to leverage and analyze how they are going to deploy the network of chargers with the energy prices rising, right? It's another important challenge. And then, of course, CO2 emissions reduction. So to be honest, in Europe, we are doing quite well. We have reduced from 1990, 40% of the CO2 emissions. It's, let's say, consistent, and it's projected to be 49% by the end of 2030, which is close to the target from the Fit for 55, but we are still 6 points below the target, let's say. So we need to increase or we need to reduce the CO2 emissions still. So there's going to be, of course, more regulations in order to make that happen. So all these, the companies have all these challenges that they can turn them into opportunities. How? Let's go a little bit more in deep to the one, from my point of view, the real heroes of the e-mobility transition, the CPOs. What are their pain points? Three of their pain points. I know they have a lot of pain points, but three of their pain points are the following. First of all, limited grid capacity. It's not something that happens in some remote areas or remote countries. Of course, if you live in France, this might sound a bit strange for you, because in France is probably the only country in Europe where power is available almost everywhere. But in all the other countries in Europe, grid capacity, it's a big issue. We are here to not only to talk about challenges and pain points, we are here to talk about solutions. And what is a very good alternative or solution for this grid limitation? A battery integration. Batteries, 10 years ago, the price of per kilowatt hour was more than $500 per kilowatt hour. Now it's lower than $100 per kilowatt hour. So batteries are the next wave. We have lived, or we have experienced the first wave of PVs, self-consumption and all that stuff from 5 years ago till now. And now the next wave, it's going to be batteries. And it's happening in many countries already in Europe. What does it mean to integrate a battery with a charging station? It means that with low input, you can have HPC. So with less than 50 kilowatt, you can be providing more than 150 kilowatt, up to 200 kilowatt to the car, right? This is something that is, it looks like magic, but it's not magic. It's just physics. It's just happening. You can go. Actually, I haven't mentioned that we have a stand there, and you can go there after the presentation and talk to us if you have more questions. If we don't have enough time to cover all your questions, you are more than welcome to come to our booth, and we can explain to you how this happens. Another challenge. Sometimes there's limited grid capacity, so the DSO tells the CPO, no, you cannot get the power in this location. You just get 50 kilowatt, 100 kilowatt, so everything in low voltage. Or sometimes it's very costly or very time-consuming to get the grid extension. So in some countries, like for instance Spain, where I come from, in case you haven't noticed, it takes from 2 to 3 years to get the power from the grid if you want to get 1 megawatt from the grid, right? Which is a very, very long time and can be reduced enormously if you use a battery integration. Why? Because with a low voltage input, again, you get HPC. But what does it mean? It means that while the CPO is waiting to get the power from the grid, while the CPO is waiting for all the permittings and all the approvals from the DSO, from the municipality and all that stuff, the CPO can be making money with low voltage. The CPO can get a fast deployment of chargers in the meantime as a temporary solution. So again, what we are here to bring is solutions. We are here to talk about challenges, but also bringing solutions that can help CPOs to deploy the network faster. And of course, one of the key points here, energy costs. From our point of view, CPOs should be the owners of the OPEX, of the operational costs that they have, of the energy costs that they have, right? They should be in charge of when they buy the energy, when they sell the energy, for how, what is the price they should be able to play with that, right? And this is what we believe, that with this kind of solutions, you can do peak shaving, and also with the EMS that we have integrated, you can definitely decide when you buy the energy, when the electricity prices are cheaper, of course, and then when you sell it to the grid. So you have a full control over the OpEx. Nowadays, with just the chargers connected to the grid, you depend on when the car arrives and charges, right? Because the electricity price, you cannot control that, yeah, right? You get a contract with the DSO, with the energy utility, and then you just sell it whenever the car arrives. With this solution, you can actually control your OpEx, which is very important and very key from our side. So as you can see, we go beyond today. So the chargers are not anymore endpoints, but enablers. They are active participants of the energy ecosystem. They interconnect different technologies. They exchange energy with different players. So let's analyze together how a microgrid would be built, right? Step by step. So first of all, we would have the battery connected to the charger, right? So the battery, the benefits or the upsides of having a battery integrated are several. I'm going to mention just a few. But for instance, you reduce the stress of the grid because you are taking actually more power from the battery than from the grid. Just to give you an example, with our solution, you take 150 kilowatt from the battery and just 44 kilowatt from the grid. So you reduce the stress of the grid. If you are in a very congested grid network, this is a golden opportunity for you to keep providing HPC even with the grid when the grid is congested or stressed, right? Another interesting benefit is that, of course, you can mitigate the volatility in electricity prices. If you control when you buy the electricity, when you buy the energy, and when you sell it, when you use it, you can control that. So you have more control, again, sorry for repeating, but more control over the OpEx of your projects, right? And that's, you're in the end, you're less dependent from the grid. You can even charge only with the battery. So with our solution, you can, and with this kind of solution, it's not just us, it's this kind of solutions, you can only charge with the battery, which is great. In case you have a problem with the grid, a blackout, you can only charge with the battery. Let's go to the next point of integration for in a microgrid, right? PVs. All right, PVs. We all know about PVs. They are everywhere, right? But we still don't make the link. There are some CPOs that are already installed in batteries and PVs, so this is not new for them. But for others, please think about the benefits of reducing, for instance, reducing the dependency from the grid. You can be, with the solar panels, you can be charging the car, charging the battery at the same time, and just using a little bit from the grid or nothing at all from the grid, right? You can be fully independent from the grid, which is incredible and which can give the CPO full control over the energy in that site. Another interesting benefit is that the DC energy that PVs generate energy on DC, right? They transfer the energy on DC to the battery because inside the charger there is a DC-DC power module instead of an AC-DC. So you just do one. You don't do even a conversion. It goes on DC to the battery and on DC to the car. So it's less energy losses. It means 3 times less energy losses than with an just external PV connected to a building and then providing to the transformer center and then providing the energy to the car. So it's less energy losses. And then let's talk a little bit about bidirectionality, right? It's important that we split into different let's say concepts. First of all is the bidirectionality from the battery. So from the battery we are already able to provide energy back to the grid. In some countries it's not allowed, we are not allowed, the regulation doesn't permit it, but in some countries, it's already happening, battery to grid. And this, imagine how this allows the CPO to have even more control over the OpEx, right? And there is also, but even the battery, what we are doing in some cases is battery to transformer, and the transformer is powering up the building. So whenever you turn on the AC on the building, you can use the energy directly from the battery and not from the grid, all right? And then another case is the bidirectionality from the cars. Of course, this is evolving, the technology is evolving, and by the estimations that by 2030, there's going to be on the roads 114 terawatt hour of energy going in across Europe in the EV fleets, European EV fleets. So car, vans, trucks, and so on. What does it mean? It means it's a big number, right? So let's take it down to earth a little bit. It's the consumption, the yearly consumption of a country like the Netherlands in 1 year, going around Europe, driving around Europe. So imagine how powerful this would be if we interconnected with the building and with the charger, with the battery, with the PV, and so on, right? So this would be, in the end, this is the whole ecosystem, the whole energy ecosystem, right? We have cars doing bidirectional charging. We have batteries backing up the charging and backing up the building. We have PVs generating DC energy and transferring this energy on DC to the batteries and to the cars, or even to the building. And then we have of course the transformer, the grid whenever it's needed, and we have the building connected to all that, right? So this is happening. This is happening. It's not just an idea on paper like 5 years ago. This is happening in some cases. So I really encourage you guys to come to our booth, and we can explain to you and we can give you more technical details about how you can make this happen, and you can have full control over your OpEx. So I'd like to finish, and sorry because perhaps it's taking too much time, but I'd like to finish with a couple of messages to all of you. First of all is that the future of charging is resilient. Is a resilient, interconnected, and bidirectional energy ecosystem where each charging station strengthens the grid. And resilience is not something that is built by a company or a project or a product. It's built by all of us joining forces, by CPOs, by grid operators, by service providers, software developers, by all the players working together. So let's together build let's bridge the gap to EV mass adoption, right? And the final message from my side is, again, sorry because I think it's taken too long, but it's a message that I like a lot. It's EV charging is not just powering cars anymore. They are powering the energy transition. All right, so thank you very much. Now I'm open to questions, and you can come and visit us whenever you like. Thank you.
Thank you so much, Javier. And we're opening the floor for questions. Please put the headphones on. Any questions on bidirectional charging? It's the first session of the morning. Take your time. Digest the information. See? We just need a little bit of warm-up. I'll come around here. Excuse me. 1 second.
Hello, my name is Wolfgang from Keysight. My question would be, how many microgrid installation have you already deployed in Europe?
So we have around 200 deployed that they have a battery, and a couple of them with PVs as well. Battery to grid, as I said, is still in development, so it's not actually happening. So that's why I said next in the first slide. But the technology is there. So the message is that the technology is there. So for the CPOs to come and ask questions and see, let's try to push to adapt the regulation and allow this battery to grid, so we can have many more in the future. And we have 20 also in the US. One of them doing PVs, integrated with PVs as well. And very soon there will be some doing battery to grid, because in the US it's more flexible, let's say.
Thank you. And do you have a rough prediction until 2035?
For microgrids,
Yeah.
it depends on us. No, I don't. I don't
problem.
have because we need to. We actually, and it actually depends on if you consider a microgrid only with PVs or PVs plus batteries. So it's a bit difficult to
Okay,
give
no problem.
a
Thank you.
prediction. But thank you for the question.
Thank you, Wolfgang. I'm coming back up. Oh, perfect.
Hi, thanks for a great presentation. My name is Olaf Gieteling from Rietveld. In terms of vehicle to grid, so I see sort of theoretically, right? It's a no-brainer, but the practical constraints are that people want to charge there. So how do you see? So it's more, yeah, it will probably then become like a commercial solution. So how do you see that happening in practice to convince people that to decharge their vehicle while they come there for another reason?
Thank you very much, Olaf, for the question. And I was asking the same question myself when I was preparing the presentation. So how can I explain it? So it's of course it makes more sense at least initially for commercial vehicles, right? You have fleets, and some of the cars are going to be there for 24 hours without being used. So you can use this energy, you can discharge the battery, and then you can charge it again with solar panels, right? So by doing that, and you can make sure that when you need the car for the company that is renting the cars or whatever, you have the battery the stock 100%, right? This is the change in the mindset. That's the change in the mindset. So we are moving from, okay, we just charge cars, and then we will use in fleets first, and then probably at home. Why not at home? At home, perhaps you can reduce, if you know what is your consumption. So a battery is 50 kilowatt hour approximately, the average 50, 60. That's the consumption of a house in half of the month, right? So it's a lot of energy stored there. So you can use it perhaps, and you can, if you have solar panels, you can use the energy to power your house, and then during the night, and then when there is the day starting, then you can start, you have sunlight, you can start charging again the car, right? In case you are not using the vehicle. So it's all interconnected, right? It's all related also to predictability, and when you are going to charge the car, and when forecast, also the weather forecast, it's important when there's going to be sunlight, when there's going to be a high activity on solar panels, and then you can charge the car. So I think it's going to be, it's just going to happen. We just have to implement the first bidirectional, let's say, references, and then other companies will follow, other players will follow. But I agree with you. Initially, a guy that goes to a charging station just wants to charge. But I believe that this is in 5-10 years it's gonna change. And also, let me say something. I think that the technology needs to evolve still in battery to grid, in vehicle to grid. Sorry. In battery to grid, it's already quite advanced, but in vehicle to grid, I think it still needs some development to increase the power in which you are providing back to the grid, back to the grid of the building, the energy from the car. But thank you for the question.
Thank you. We have time for one more.
Thanks a lot for your presentation. My name is Vasev. I'm from Energy Innovation Center. My question is, do you guys also do the studies, like how big a PV panel is required for a particular site and what battery we should have, like studies like this, or only operational management, or also like before operation management?
Yeah, so thank you for the question. We are an R&D company and manufacturing company, right? So we manufacture, we design, test, and produce the solutions. So the charger integrated with the battery, right? We don't produce the PVs. However, we are going more and more upstream, and we are doing also consulting to our partners, and we are providing some case studies and some analysis of how they should be using the solution with the battery, and if they install PVs, we can make a quick study. We have a few Excel files, a few templates to help them, to support them with this transition. But of course, as a manufacturer, it's not our key role, let's say, to provide these services. But in some cases, we do it, yes, we do it. Especially with the charger and the battery. A bit less with the PVs, but with the charger and the battery, yes, we support with that. We analyze the consumption, the daily consumption, monthly consumption, yearly consumption, and then we provide an estimation of the capacity of the battery that they need. In some cases, it's just 215 kilowatt hour. We are talking mostly about CNI, all right, CNI projects. In some cases, it's 215. In some cases, it's 430 kilowatt hour, which is half a megawatt hour. So it's, yeah, it depends. With PVs, sometimes we also support. Thank you. Thank you for this.
Thanks a lot. Thanks a lot for your answer.
Thank you.
And by the way, just one last comment from my side.
No,
Sorry.
please take your time.
We have a charger that has been already tested in 200 locations. The one that I was mentioning before, we have it actually outside. So the charger that you can see outside is our own solution integrated with batteries. And you can see that with just a simple AC connector, the charger is providing fast charging. It's about 164 if I'm not wrong. So the battery can provide 150, and there is only 14 kilowatt available from the grid. So we are using a combination, and there are cars charging every day. So after the trade fair every day, I see that the battery is empty because it's been fully used, let's say. So it's great news.
Very exciting. Congratulations. That's very exciting. Thank you so much for painting such a big sustainable picture for us. And thank you so much for your very insightful session.
Thank you.
Everybody, let's give it up for Javier.